All right, welcome back to my YouTube channel. This will be the part three of graph of a linear equation. Right now we're going to be focusing on getting of drawing the graph. Right. So I have listed some things that will be very essential to draw the graph. One of the thing is we need dates. Yeah, dates is very important. Okay. The title of the graph. The title of the graph must be written. Like this graph now, it will be a graph of y against x. Other signs subject to those ones will be more detailed and more specific. But for this one, the title of the graph will be is either a graph of a linear equation or y against x. Okay, the scale also will be needed. We need to label our axis. Okay, this is the x-axis, this is the y-axis. If it's other subject, maybe you are asked to plot a graph of, let's say, the current against the velocity. If the current is at the y-axis, you need to specify showing at the axis that this axis is for current, while this axis is for the volt. Okay, so the axis needs to be labeled and together with the units. Right. The next is the coordinate. I'm talking about the points. Each value. Okay, when x is 1, 5, sorry, y is 5, you locate the points there, either with a dot or with an asterisk or with a small hole. All right, best line of fit, and that's the line itself. Sometimes the best line of fit can be a curve, it can be a straight line, and sometimes all points might not fit in to the best line of fit, but it must be well distributed. Okay, slope and intercept. We need to get the value for our slope, we need to get the value for our intercept. But for this class, we're not going to be getting the slope and the intercept. So we just deal with dates, title of the graph, the scale, the axis, the coordinates, especially the coordinates, then the best line of fit. Okay, we'll still be using our value. This value is y equal to x minus 5. Okay, so is it minus 5 or minus 3? Minus 3. Yeah. Okay, so the dates, okay, this is my graph. Okay, so the date is 15 June 2024. Right, the title of the graph. Some graph book will have this, some will not have. So how are you? Right, let's see, a graph of y of y against x. But I think what we should just consider is a graph of a linear equation. Yeah, a graph of a linear equation. Now let's write the equation. Y equal to x minus 3. I think, yeah, this should be the title of the graph, or a graph of y equal to x minus 3, or a graph of a linear equation y equals to x minus 3. Yeah, this should be the title. The title should be the equation, a graph of y equal to x minus 3. Okay, so I haven't discussed about the graph. Now the scale, very very important. Before we pick a scale, then we need to look at the values we are having. For x, we're having minus 3 to positive 3, and then y, we have negative 9 to 3. And this is how our graph look like. So with your eyes, you try and glance through, okay, what line will best fit. If the values are very high, then we need to take a scale that is high. We're looking at this value, it just ranges from minus 3 to positive 3. That's the lowest number for y is negative 9, and the highest number for y is 3. So it means I can take each of these box 1 1. What I mean is this 0 1 2 3 4 5 6 7 8 9, and if I take this, it's 1 2 3 4 5 6 7 8 9. Or you can decide to say, okay, for every 2 box I'll give it 9, but that would be too much. So that would be too much. So let's say I want to follow, let's say 9 8 7, sorry, that's minus 9 minus 8 minus 7 minus 6 minus 5 minus 4 minus 3 minus 2 minus 1 0 1 2, and we have the highest number to be 3. So the best we can do is to actually say, for each of the small box, you should range from, you should be going in the order of 1 1 1 1. Yeah. So y for the x-axis, we have negative 3 to positive 3, so it's stable. We can now listen, for this we can say for each 2 box represents 1 unit. So this is 1 2 3, since it can contain. So we just want to have a very very good graph that one can read very well. Yes. So I think what we should take for the scale, some graph will not have this. Yes, so you just need to provide it if your graph is not having this. So the scale we'll be using will be, all right, so for each of this box is 1 centimeter, but the standard is 2 centimeter. So for the x-axis, I'll just write 2 centimeter represent 1 unit. Let me explain it again. For the x-axis, this is the x, this is the y. So for the x-axis, this is the origin, 0, 0. So 2 centimeter represents that. I'll be count 2 of these box, you say 1 2. So this will represent 1. Sorry, we don't use pen for graph. I just, so that you're going to see it very well, that's why. And this 2, and this 3, this 4. So every 2 boxes represents 1 unit, and this -1, -2, -3, -4. You see it? So everything towards the right is positive, towards the left is negative. And then for the y-axis now, let's say 2 centimeter represents 2 units. Remember, we're going to be picking 1, 2, 3, 4. So instead of saying 1 centimeter represents 1 unit, I just decided to use 2 centimeter represents 2 units. The standard is 2 centimeter. So if this is 1, this is 2, this is 3, 4, 5, 6, 7, 8. Now I want you to look at it. 2 centimeter. Now it's 2 boxes. 1, 2. This is 2 unit. 1, 2. It's moving in the order of 2. So it means 2 centimeter represents 2 units. And then for the negative side, -1, -2, -3, -4, -5, -6, -7, -8, -9, -10. All right, so this is what we have. So let's see. Of chosen the scale. I don't think we've labeled the axis, so let's label the axis. This is y axis, this is x axis, this is negative x axis, and this is negative y axis. Okay, so these are the values. Okay, let's see the next thing. The next thing is the coordinates. Okay, so I want you to pay attention. Now the first is -3 and -y. So when x is -3, y is -9. I hope you remember this is what coordinates means, what we did in the previous video. Okay, so -3, -y. So I'll go to the x-axis. Where do I have -3? Let's locate it together. So this is my -3 for x, and let's go to the y-axis. The y-axis is -9. Put your hand at this -3. Let's look for -9. This is -9. This is -9. So we're going to trace it to where they meet. I'm going to trace it to where they meet. Okay, let's trace it together. You can trace it to a ruler. This is -3. I'm tracing it down, and that's because -9 is down. So I'm going to go to -9. I'm going to trace it towards the left, and that's because -3 is towards the left. Right, they meet at this point. So this point is -3, -9. I hope you understand. Okay, let's pick the next one. -2, -2 and -7. When x is -2, y is -7. Okay, you can pause it and try and figure it out. So this is x, -2, and this is 7. So we're going to try it still. We'll trace it. Sometimes you might not trace it. You can just use your eyes and trace it. It's along this point. -2, -7. But if you're going to get confused, it's better you just trace it out. So I'm going to be drawing the remaining points. Let's go. Let's do it together. -1 and -5. So this is -1 and this is -5. It's not compulsory you write the coordinates beside it. I just want you to know, that's why. But if you want to write it, there's no problem. The next one is 0 and -3. So I want you to pay attention to this. At this point, we have 0, 0. This is the point we call the origin. So x is 0. So it means we're not going to be changing, we'll not be moving for x. The only person will be moving for, or the only thing variable will be moving for, is y. Do you get it? So 0 for x is here. For y, we're going to trace it. For -3, it is here. So the only movement we'll be moving is for y. So at this point, x is 0, y is -3. Okay? So the next is 1 and -1. When x is 1, y is -1. So I'll look for x as 1, y as -1 is here. So I'm going to trace it down. I will trace it towards the right because +1, positive values are towards the right. So this is 1, -1. All right, so the next is 2, 1. That is when x is 2, y is 1. When x is 2, y is 1. So it will be at this point. All right, the next is when x is 3, y is 3. When x is 3, y is 3. So it will be at this point. When x is 3, y is 3. When x is 2, 2, 1. All right, so this are the lines. So the best thing now is we're going to draw this line, a very straight line. I'll cut across this all through, and that will now give us our baseline of it. So I'm going to be drawing a straight line. All right, I've said it before, don't draw with pen. I just drawing this so that you're going to see it very, very, very clear. Now, one of the things I want you to note is a graph, a straight line graph, don't leave it hanging. Can you see that my value for x cuts through the graph, and also this cuts through the graph? Don't leave it hanging on her. So this is how to draw a graph. The title of the graph, once again, is a graph of y equal to x minus 3. And sometimes on this graph you can write y equal to x minus 3. Anyway, something nice, just make your graph look more detailed. All right, so we have our scale. If you don't understand, just try to listen to the video and watch the video again. So we talked about axis. From our scale we got these values. And then the next thing we considered was the coordinates. When x equal 3, y equal 3. So, and all these coordinates we got it from our table. So, and this will be the end of this topic. We try and solve a question from the beginning to the end. So thank you very much. If you've not subscribed, please subscribe, like, and share. God bless you.